I'm going to do a demo to show all of the vocabulary and concepts from this unit. And the piece of equipment we're going to be using for the demo is a toy some of you might have encountered before that I call a popper. It's a little piece of rubber. It looks like sort of it's a half of a sphere. And if we just set it on the table by itself, it doesn't really do anything. And that's because it doesn't have what we call any of what we call energy. Energy, which is what this chapter is all about, just describes an object's ability to do stuff. And right now, this thing by itself can't do anything. And so what I can do if I want to give it some energy is I can do work on it. And the way that we do work on something is by applying a force to it while moving it, while displacing it. And so if I take my thumbs and push and flip this thing inside out, so I'm applying a force and moving it while I push it, now I've stored some energy inside there. And now if I set it down, we can see it now has the ability to do all sorts of stuff. In this case, it was able to start speeding up, go up into the air, slow down, and then come back down and bounce around on the table. So the different types of energy that are involved there. First off, the energy actually had to start out inside of me. One of the key concepts from this chapter is the idea of conservation of energy. Energy can't be created or destroyed. It has to come from somewhere, and it'll always wind up going somewhere. It'll never disappear and never appear out of nowhere. So there was energy stored inside of me, and I was able to transfer that into the popper by doing work on it. And while it was stored inside the popper, while it was stretched inside out, that's what we call elastic or spring potential energy. It's energy that is stored inside of it. It has the potential to do something. When it was just sitting there, it wasn't actually doing anything, but it had the potential for a little bit while it was just sitting there to do something. And so anytime it has the potential to do something, we call that potential energy. When it pops, that potential energy converts into a different kind of energy. Since energy can't be created or destroyed, however much potential energy we started with had to become a new kind of energy. And since it started moving, it had the energy that is associated with motion, or what we call kinetic energy. As it went up into the air, we know as things go up into the air, they will slow down because of gravity. And if it's slowing down, that means it's got to be losing motion energy. But since energy has to be conserved, it has to be gaining some other kind of energy. And so the kind of energy it's gaining is called gravitational potential energy. Gravitational potential energy refers to the potential that any object that's up in the air has to eventually fall and start moving and doing stuff to whatever it lands on. And so the higher up in the air it goes, the more potential it has to fall and do something later. And it has to slow down as it goes up in the air, because when it's losing its kinetic energy, it's got to be gaining gravitational potential energy. And since energy is always conserved, however much energy I lost in the first place is how much elastic potential energy it gained. That's how much kinetic energy it had then. And then as it goes up into the air, let's say it started with 4 joules of kinetic energy. As it goes up, it starts to slow down. Now it has 3 joules of kinetic energy. Well, if it had 4 joules of energy total, it must now have 1 joule of potential energy. As it goes up higher, it's going to be going even slower. So maybe now it has just 2 joules of kinetic energy, which means it has to have 2 joules of potential energy. So it has 4 total. As it gets even higher, it slows down even more. Maybe it only has 1 joule of kinetic energy now, so it has to have 3 joules of gravitational potential energy. And at its highest point, when it stops moving, it's got to have 0 joules of gravitational potential energy. But since the total energy still has to be 4, now it has to have 4 joules of gravitational potential energy. As it falls back down, the process just reverses itself. So as it gets lower and lower and lower, it has less gravitational potential energy, which means it falls faster and faster and faster because that potential energy gets converted into kinetic energy. At the end, it hits the table and it sort of bounces around, and then it eventually stops moving. Which at this point, it might seem like the energy has disappeared. And indeed, the popper doesn't have the energy anymore, but the energy still exists in the universe because energy has to be conserved. that energy has now been converted into heat, which is just random molecular motion in the table and in the air and even a little bit in the popper. But it's no longer useful energy. It's no longer kinetic or potential energy. But that energy still exists in the universe. It's just warmed up the universe a little bit as it bounces around on the table, and things like friction cause it to come to a stop.